Okay, so in this video I'm going to look at the Leaving Cert Higher Level Maths Paper 2, 2017, and I'm going to have a look at questions 3 and 4. So this is question 3 here. Question 3 involves a triangle ABC. We have the coordinates of A and C, and we have the coordinates of this point here, G, which we're told is a centroid of the triangle. We're also told that AG intersects BC at a point P. In other words, if we were to continue this line on here, this point here is the point P. We're also told that the ratio AG to GP is 2 to 1. So that length there is twice this length here. Now, just a couple of things. First of all, a centroid of a triangle is where the medians of the triangle intersect. And the median is just where you take a vertex, drop a line to the opposite side, to the midpoint of the opposite side. So this point here, P, is the midpoint of the line segment BC. That's going to be useful later on. So if you take this point C here, drop a line to the midpoint of its opposite side, it will also go through this point G here. So if you draw three medians, the intersection of those three medians is the centroid. Okay, so the first thing we're going to do is find the point P here, and we're going to do that by using this formula here, which I've written in. This wasn't part of the question. This wasn't printed as part of the question. You had to know this. So this is this here is gives you the coordinates of the point G here. So in other words, this part here is 2/3, and this part here is 4/3, and this point here, G, divides the line segment AP in the ratio A to B. In our case, A is 2 and B is 1. So it divides the line segment AP in the ratio 2 to 1. So we know that this part here is 2/3. So we can write down 2/3 is going to be equal to B times x1. By the way, I'm just going to call this here x1, y1, and I'm going to call P here x2, y2. We're going to work out what x2, y2 are. So we know that 2/3 here is going to be equal to this here. So B is 1. We can see B here is 1. X1 is 0, so we can put 0 in there. A is 2, so we're going to put a 2 in here. And x2, then we don't know what x2 is. That's what we've got to work out. So we're going to put that in there. That's all over A plus B, which is just 3. 2 plus 1 is 3. So when you work this out, then you get, I'm just going to cross multiply here. So it's 3 times 2 is 6, and 3 times, this is just 0 here. So it's just 3 times this part here. So that gives me 6 times x2. So that will just give me x2 is equal to 1 divided across by 6. So I know that this here is 1. Okay, let's do the same for the y coordinate. So we know the y coordinate here, this part here is going to be 4 over 3. So we're going to write down 4 over 3 is equal to b times y1. So b is 1, so it's 1 times y1. So our y1 here is 6, plus a times y2. So our a is 2. So it's 2 times y2. We don't know what y2 is. And again, it's over 3, a plus b, which is 3. So cross multiply again. So 3 times 4, 12. And that's going to be equal to 3 times, well, this is just 6. So 3 times 6, 18. Plus 3 times 2y2 is just going to be 6 times y2. Let's bring this 18 over. Subtract 18 from both sides. You get minus 6 is equal to 6 times y2. That gives me a y2 of minus 1. So I know that this is minus 1 here. Okay, so the point P then is 1 minus 1. Okay, and now we've got to find the coordinates of B here. That's the next part of the question. Now, what we're going to do here to do this is, we know that because this here is the centroid, we know that this median here meets the opposite side at the midpoint. So we know that 1 minus 1 is the midpoint of the line segments BC. So we're going to use the midpoint formula to work this out. So our midpoint formula is just, again, it's x1 plus x2 over 2, y1 plus y2 over 2. So it's just really the average of the x, the mean of the x's, the mean of the y's. So let's do that. So we have p here is 1 minus 1, and we have c here as 4, 2. Okay. Now I'll call b here x1, y1. So I'll just call it x1, y1 here. So I know that the x coordinate is going to be 1. So this is 1, and that's going to be equal to 4 plus my x1, if you like, over 2. So that gives me, remember this here is x2, y2. This is my midpoint, and b here is x1, y1, if you like it. So what do I get here when I do this? Well, 2 times 1, 2, multiply across by 2, and that gives me 4 plus x, so that gives me x is equal to minus 2. Okay, so I know that my x1 here is minus 2. Just got to work out the y1 now. So what do we know? Let's see. Well, my y coordinate here for the midpoint is minus 1. So that's just going to be equal to cy1 here, which is, or y2 rather, which is 2, plus my y1 divided by 2. So that's just going to give me minus 2 is equal to 2 plus y1. So that's just going to give me a y1 of minus 4. So this is minus 4 here. Okay, so that's it. I have my coordinates for b here. Just write it in here. So that means b is minus 2 minus 4. Okay, now I think I've actually, let's see, have I drawn this? Yeah, I have this drawn here. Sorry, let me just go back here and down to here. Yeah, this is it here. So I've drawn this on GeoGebra, and I've drawn in the points here, A, B, and C, and I've drawn in the midpoint here, 1 minus 1. And the sides, I've drawn in 2 medians here, this one here and this one here, and the points do actually match up here. The next part of the question involves an orthocenter. So if we look at this here, we've got to prove that C is the orthocenter of the triangle ABC. So in other words, if we go back here, we've got to prove that this point here is the orthocenter of the triangle. Now an orthocenter is just where the altitudes of a triangle meet. So if we go back up here to our triangle, so this is our triangle. So we want to prove that this point here is the orthocenter. So if I draw a triangle here, for example, like this, to find the orthocenter of a triangle, what you do is you find the altitude. So this is one altitude here. You take a vertex, drop a line down to the opposite side at right angles to the opposite side. So it's an altitude, it's the height of the triangle, taking this as the base. So if, for example, I take this here as the base, well, if I drop the right angle from the opposite vertex here, let's say that's the right angle there, well, this point here is the intersection of the two altitudes, or if I can do another one up here, it'll go through it as well. This here is my orthocenter. So if C is the orthocenter of this triangle here, that would mean that this line here and this line here are altitudes of the triangle. So in other words, for this to be an altitude here, you take this point here, drop a line down to the opposite side, so this angle here must be right angles. Same here, if this is my base here and I drop a if I drop a line from here up to here, if I take this as the base here So this would be my altitude here, so this would have to be right angles here as well. So in other words, I've got to show that this is a right angle triangle and this is a right angle at C here. So how do I do that? Well, there are a few ways of doing it, but the way I'm going to do it is to find the slope of this line, find the slope of this line, multiply the two slopes, and I should get -1 if this is a right angle. In other words, if you have the slope of two lines, you multiply them and get -1. It proves that the two lines are perpendicular. That's the way I'm going to do it. Now another way you could do this, just off the top of my head here, is maybe to find this distance here using the distance formula and this distance, and you can use Pythagoras' theorem then to show that this is a right angle triangle, and the right angle will be opposite the longest side. So that's another way of doing it, but I'm just going to do it by slopes. I think it's a little bit quicker. Okay, so let's work our way down through that. So prove that C is the orthocenter. So we're going to first of all find the slope of the line segment BC. Okay, so remember again that B here is -2, -4. C is 4, 2. So remember the slope then, you can write the formula down. It's just slope is going to be y2 minus y1 over x2 minus x1. So whichever one you want, this could be x1 y1, x2 y2, whichever way you want to do it anyway, but it's going to be difference of the y's over difference of the x's. So let's take 4, have I got that right? B is -2 minus 4, C is 4, 2, yeah, that's okay. So it's going to be 4, actually, have I got that point correct? Let me just double check that. B is -2 minus 4 and C is 4, 2. Yeah, that's okay. So I just got to double check this before I continue on. So let me just do difference of the y. So it's going to be 2 minus -4. 2 minus -4 over the difference of the x's. So it's going to be 4 minus -2. So if I do that, I get 2 plus 4 here, which is 6. 2 plus 4 here, which is 6. So my slope here is 1. Now I'm going to find the slope of AC. So remember, A here is just 0, 6. So again, do difference of the y's. So we're going to do AC, difference of the y's over difference of the x's again. So it's going to be 2 minus 6 over 4 minus 0. So here I'll get -4 over 4, so that's just going to give me -1. So if I multiply the two slopes then, so in other words, m1 times m2 should be -1. So m1 is 1, m2 let's say is -1. I do get -1, therefore BC, the line segment BC, is perpendicular to the line segment AC. Therefore, if you want to write this out properly, therefore BC, the line segments BC and the line and AC here are altitudes of the triangle ABC. Therefore, you can say the size of the angle ACB is 90 degrees. Therefore, C is an orthocenter of the triangle ABC. Okay, so that's it for question 3. Let's move on to question 4. Okay, question 4 here involves a circle, and we're given 3 points on the circle. So what we've got to do is find the equation of that circle. Now again here, I think I have drawn that here somewhere. Let me just see if I can find it here. I think I must have. So here we go here, yeah. So this is the circle, and I've drawn in the 3 points here. I've 0, 0, 6, 6.50 and 10, 7. And GeoGebra here has drawn the circle for me. I've drawn this triangle here as well because we're going to use that in the next part of the question. And GeoGebra has done all the calculations for me and has worked out the equation of this circle, so that I'm just sure that I have my calculations correct. So obviously you wouldn't have this in an exam, but it's a useful tool if you're not in an exam to use GeoGebra to draw these particular shapes, just to be sure you have your calculations done out properly. So let's go back and work out the equation of this circle ABC. So we have 3 points on the circle, so what we're going to do is use simultaneous equations with 3 unknowns to work out our f, g and c. So let's write down the general form of the equation of a circle first of all. So it's going to be x squared plus y squared plus 2gx plus 2fy plus c equal to 0. Now we're going to start here with 0, 0. This is a very handy point to put into equations because it usually cancels quite a bit of quite a few terms. So you can see that it's going to work here for x and y and all of these terms except c. So we're going to end up with 0 squared plus 0 squared plus twice g times 0 plus twice f times 0 plus c. So that will just give me c is equal to 0. All of these will just give me 0, so I'll just end up with c is equal to 0. So that's very handy. Next one is 6.50, so let's put that one in. 6.50. So if I do that, my x is 6.5, so I'll end up with 6.5 squared. Y is 0. Twice times g times 6.5 plus twice f times y, which is 0. And c is 0, so I don't have to worry about that, so I end up with 0 here. Let's multiply all this out. So I'll end up with 42.25 here plus 2 6.5s times g, that will give me 13g. This will just be 0, and I'll end up with 0 here. This will give me 13g is equal to minus 42.25, and finally that will give me g as minus 13 over 4. Okay, so we've got c and we've got g fairly easily. We've now got to work out what f is, and to work out what f is, I'm just going to use the last point that I was given, which was 10 and 7. So let's put that into our equation. Well, we end up with 10 squared plus 7 squared plus twice g times 10 plus twice f times 7 is equal to 0. And in fact, you know, here I know what g is, so I might just stick that in at this point here just to make it a little bit easier. So I'll just put in g here is minus 13 over 4. Okay, so let's move on then. So we've got 10 squared, which is 100. We've got 7 squared, which is 49. This here, well, I'll work that out in a couple of minutes actually. Work out all 3 together. So it's going to be 2 10s, 20. So it's going to be minus 20 times 13 over 4. And here we'll end up with 2 7s, 14 times f is equal to 0. Okay, look, 100 plus 49 minus 20 times 13 over 4, that just gives me 84. It's just calculator work. You can do that fairly quickly on your calculator. It's equal to 0. So here I'll end up with 14f is equal to minus 84. So then I just end up with f divided by 14 gives me minus 6. That just gives me minus 6. Okay, so now we have G, F and C. So finally then that will give me the equation. Hopefully, let's just write it all down. Remember, the equation of the circle was x squared plus y squared plus 2gf, sorry, plus 2 gx plus 2fy plus c equal to 0. So our final equation then is x squared plus y squared plus twice the g, so remember the g was minus 13 over 4, x plus twice the f here, which was 6, minus 6 actually, times y. C was 0, so that will give us finally x squared plus y squared minus, this becomes 6.5, in fact 6.5 x, this here will become minus 12y, and that's equal to 0. Okay, so that's the equation of the circle, and I think in my actual calculations here we do end up with that particular equation somewhere here. You may not see it here, but I'll just see if I can drag it over here. Yeah, this is the equation of the circle that GeoGebra has actually worked out, so it's the exact same as what we got doing our calculations manually. Okay, so let's move on to the last part of question 4. Find the angle BCA. Give your answer in degrees, corrected 2 decimal places. So BCA. So the angle we want BCA. So we want this angle here. Now GeoGebra has worked it out for me as 28.44. So let's see if we can do this manually. See, do we get that particular angle, that particular value there. Now the way I'm going to do this is I'm going to find the distances, 3 distances of the 3 sides of the triangle. So I'm going to find the distance from A to B, the distance from B to C, and the distance from A to C, and then I'm going to use the cosine rule to find the angle at C here. So I know this angle, or this length here along here, we already have it. We know that the distance from the origin out to the point B is just the x value, which is 6.5. So I don't have to use the formula to do that. I should spot that straight away. So I really got to use the formula to find this length and this length here. Now GeoGebra again has calculated these distances for me, and I'm just going to do it manually just to confirm, just to work out these distances, because as I say, you're not going to have this as in an exam. So let's start then. So we're going to work out first of all the distance between B and C. The distance between B and C. So the distance, remember our distance formula, the distance between 2 points is x2 minus x1 to be squared plus y2 minus y1 to be squared. This is our distance between 2 points. So again, B here, I'll write the points down here. B is just 6.50, and C is 10.7. So I'm going to say x1, y1, x2, y2 here, and then you just stick them into your formula. So it's going to be 10 minus 6.5 to be squared plus 7 minus 0 to be squared. That's just going to give me 10 minus 6.5 to be squared is 12.25. Plus 49. So that just gives me the square root of 61.25. And that's correct given what GeoGebra has worked out for me. So now I'm just going to work out what A and the distance from A to C is. So again, it's just the same thing again. So we have the point A here is 0, 0. 0, 0 here. So again, from the distance from these 2 points here. So again, you can just stick them into your formula. So it's going to be 10 minus 0 to be squared plus 7 minus 0 to be squared. So that's just going to be the square root of 149. Okay, so we know the distance from B to C, we know the distance from A to C, and we know the distance from A to B. We know the distance from A to B is just going to be 6.5. That's along the x-axis. Okay, so now we have these three distances here. We have this one, and this one here. So remember, I'll just go back to the triangle again here. So it's just going to be, remember, this here is the angle. This is the angle we want to find. So I'm going to use the cosine rule to work out this angle here. So I'm going to start on the left hand side of the cosine rule with its opposite side, this side here. So we're going to start with AB here. AB, the opposite side in this particular case, AB. So 6.5 is going to be on the left hand side of our equation. 6.5. So let's write that out. Remember, the cosine rule is, just write it out here quickly. So it's going to be a squared is equal to b squared plus c squared minus 2bc cosine of a. This is what's written down in the table. So we're going to start with this one here, which is going to be this side here first of all. So we're going to start with 6.5 squared is equal to the other two sides squared. Well, this is one side here. We'll take this side here. So it's 61.25 squared, which is just 61.25. Plus the other side squared, square root of 149 squared is just 149. Minus twice the square root of 61.25 times the square root of 149 times the cosine of, we'll call it A here. This is what we're looking for, this side here, A, or this angle here, A. So let's just multiply all this out. It's just a lot of manipulation and calculator work at this stage. So 6.5 squared is 42.25. Now if I add these two here, I get 210.25. If I multiply these three here, I'll get 7 times the square root of 745, and then we have the cosine of A here. Okay, so now what I'm going to do is I'm going to take this, I'm going to subtract from both sides 210.25, so I'm going to bring it over here and subtract, if you like, and then I'm going to divide by minus 7 root 745. So what I end up with when I do that is on the top I end up with minus 168, and then I divide by the minus 7 root 745, and that gives me the cosine of A here. So let's just finish it off then. So that gives me the cosine of A is going to be equal to 0.08792919, and it goes on a little bit after that. So all you got to do is get the cos inverse, the cosine inverse of this number here, and you end up with the angle at A being 28.44. And I think we were asked to do it to 2 decimal places? Yeah, correct, to 2 decimal places. So that's our angle. And if we look at this here, we do actually get, it's actually called C here. I called it A in my question, but I'll just correct that in a second. But the angle is actually 28.44. So just to go back to the question then, I would say just the answer here. Just answer the question that you were asked. So the angle BCA is equal to 28.44 degrees. Okay, and that's it for questions 3 and 4.